So good afternoon, everybody. It's 4 p.m. It's the time to start our last Epic Members New Product Release meeting before summer holidays. Or well, for some of you, perhaps even during summer holidays. So it's a pleasure to be here today. My name is Antonio Castelo. I'm Technology Manager at Epic, in my particular case in charge of lasers and biomedical. And it's great to see what is happening in terms of new developments. This type of meetings is where our members present their new solutions, talk about the new developments, and it's an opportunity also to talk about what was launched in the last months. So we'll have interesting presentations today by VPIphotonics, Imagine Optics, Cycle Lasers, AEMtec, and also TEMATYS. Unfortunately, Häcker Automation, we will not be present today, but we can upload the presentation in the website of the meeting so you can check afterwards what they were presenting. Just a few words about Epic. So in case somebody doesn't know what is Epic, is an association, a consortium of more than 800 members related with photonics technologies. You can see here the logo of all these 800 companies related with quantum technologies, laser, optical components, also integrators of some of these technologies, sensing, metrology, spectroscopy. So we cover all the technologies and the different applications where photonics is nowadays, and are more and more, as we see in our meetings and also in the projects where we are involved. And this is a summary of the benefits that we give to our members. So we help with access to market reports, also learning about new markets, with activities like these online meetings and the technology meetings where people can network and can also show their technological needs in order to connect with other people. We help with human resources and also with investors. So if there is something, you are a Epic member, if there is something that is worrying you today, feel free to contact us with your request, and we will try to help by connecting you with somebody that has the expertise to solve your issue. And regarding networking that I mentioned, apart from this meeting, we have a list of other events. Most of them before summer. We will have different physical meetings, delegation trips to Taiwan and India, also a technology meeting on industrial laser processes, and we will be present in the W3 Fairs and ECOC. So I encourage you to go to the website of Epic to see to all the activities that we organize, both online, on site, and also during these exhibitions where you probably are present as well. And we will have also online meetings. Last one before August is one about the impact of US tariff, that this is something that is worrying a lot of our members. So our director Carlos is selecting a few speakers to give some advices, tips, or share experiences about what's happening with the exports to US and how can the issues be solved together. In September, we will be back with different technology meetings, as you can see here, and also an interesting sustainability group in October talking about the standards. And just to highlight a couple of events that I will be also the moderator and the organizer. So as I mentioned, the one industrial lasers processes in Optoprim to talk about how these lasers are used nowadays in different automotive, aerospace, semiconductor, etc. applications. Also one in photonics metrology systems that I think will be interesting for some of you. And also one in photonics for bio and life science, where we will talk about the use of peaks in biosensors and also point-of-care devices and wearable devices for bio applications. So feel free to reach me afterwards if you are interested in discussing your participation in one of these events. Nothing else from my side. As Chris mentioned, that I will be short, and in order to have more time for you to speak, it's a pleasure to start with the presentations today. We will start with Marcus Verhoeven, his co-founder and the co-owner aspect system at the company AEMtec, and he's going to present the expanded test service portfolio. So Marcus, the floor is yours. You can start sharing your screen.
Okay, thank you.
In the meantime, I just can share that AEMtec is a nice company in Berlin, manufacturing micro electronic, optoelectronic modules and systems. So I'm sure presentation is going to be really interesting today, Marcus.
Okay, thank you for a nice introduction. Yes, Aspect is joining AEMtec since beginning of this year, and we brought various new services and expertise on board. AEMtec is well known as a custom advanced packaging service provider up to system integration. And today I will inform you about 3 areas where we make the organization even stronger. Short overview, and then we will step into some details about test services, custom test and automation solutions, engineering services, and a bit unique, but on top of that, we provide a specific source measurement unit as a product. So let's start with the overview. So all the things we can do within AEMtec is we have strong key expertise in hardware, software, mechanics, and optics design. From that, we support applied technology expertise in optoelectronic testing, automation, embedded systems, and we have a very strong background in imaging. Based on these core expertises, we provide test services from wafer level test up to end-of-line testing. Semiconductor industry, photonics industry is very strong in innovation. So there are many off-the-shelf solutions, but here and there, the industry is missing tools. And based on this key expertise, we are able to provide such kind of specific test and automation solutions. Likewise, we provide services also in the product development. So on one hand, this is with a focus to improve design for manufacturing, but also to enable custom specific features if you need them to speed up your product development. And on top of that, based on this expertise, what happened to us is we need a huge amount of source measurement units. And if you have this key expertise in-house, we decided to develop our own source measurement unit, which is very helpful in all our testing, characterization, and qualification domains. On top of that, the way we act is when we do not have expertise in-house, we don't mind to take care to use external resources to fulfill your requirements. Let's start with an overview of test services. So all the way from wafer testing or frame probing, we can support test services over final testing up to end-of-line testing. Just to give you some examples, we realized this for CMOS image sensors with 2,500 pads supporting 192 gigabit transceivers running at 6.6 gigabits per second. So aggregated, we have to do this kind of tests on wafer level to acquire 1.2 terabits per second with custom protocols, for example. So we realized turnkey solutions for these kind of test service requests. And it goes up the way for RF testing or X-ray detectors. At least as a service provider, we don't mind. Please send your device and test specification, and we take care that we can support related test service for you. The intention is 2 main things in testing. One is quality control of your products. The other big subject is process control. The sooner you can detect any yield loss, the better you can have feedback to the process steps to adjust process parameters. Next part is custom test and automation solutions. Based on these key expertises we have, we realize, if necessary, custom specific test modules, custom specific wafer AOI, or custom specific active alignment solutions. Just to give you a brief idea, this situation here, I was very surprised by myself that a client said, okay, we need a very specific wafer AOI. I thought all these wafer inspection tools exist on the market. But as mentioned before, the industry is quite innovative, and therefore we realized a full automated solution to provide custom-specific solution for wafer AOI, or an automation solution for active alignment. This is based on a Bosch conveyor system. So on this conveyor, two components come along, a camera board and the lens. Within this machine, we pick these components and align the lens against the camera module. Then there is a gluing process and end-of-line testing, and then it comes on the conveyor out of this system. These kind of solutions are supported to increase your test coverage and to enable automated manufacturing. Next area is engineering services. So we help our clients to develop their products. This could be just in the area of firmware development, but quite often we help clients with new ideas. In this example here, our clients had an idea to realize a new detector system for proton therapy, and it's a huge data rate we have to handle. It's in the all-over system. We have 24,000 strip detectors. Each is sampled with 1 gigasample per second. So aggregated, we have to deal with 24 terabits per second. It's not possible to transfer this amount of data directly into the PC. So in these kind of development projects, we realize all the necessary PCBs, the mechanics, the chip-on-board technology. We debugged and wafer tested the ASIC. You cannot see, it's below this metal bar here. And then all the necessary firmware to extract the raw data and transfer it to the PC. Okay, all these design services, it's to help and enable your technology, and two key focus areas to help our clients here is that we keep an eye on design for manufacturing, that we enable manufacturing with high yield, and also design for test, of course. Okay. The last area is our product. As a small test service provider with a huge amount of different activities, characterization, qualification, and production testing, we need a lot of source measurement units. As mentioned before, with all the expertise we have, we developed it in-house to support these different test areas. It's a very modular system, 16-bit source measurement units with 4 channels plus minus 70 milliamps, and then you can combine it with some digital IOs. This is a kind of baseline in testing to have these kind of instruments and huge amount of channels. So in some test configurations, we have hundreds of source measurement units or thousands of digital IOs. Use cases, it's benchtop, modular instrumentation, or turnkey solutions. That's it from my side, and don't know how much time we have to answer your questions.
So yeah, we have time for questions. So you can use the chat box or raise your hands. I have perhaps a first question. As you mentioned, the difference between design for manufacturing and design for testing.
Yes.
What's the difference in the concept from your point of view?
So in many areas, when people have new ideas for new products, the focus is strongly on the functionality of your new idea. But when it comes to cost-effective production, then these two areas, design for manufacturing and design for testing, is very important, that you take care in your system design that test cost is low, and when you look to complex assembly processes, if you use in your design, for example, if you go to the edge of the design rules, then it's the risk for having yield loss is quite high. And the services we provide, we know our technology, and then we can help the client to improve the design that you can have cost-effective manufacturing.
Okay. Okay. You also mentioned that you have different services in terms of design, different options, also the automation solutions. Do you also integrate like solutions from other manufacturing of software? Do you develop your software tools to help in the design process?
Yes, in general, it's when you think about this overview here, you can see that we have, let's say, key expertise in basic firmware and software design. But together with our clients, we look into the requirements and then we try to figure out what's the best way to have a cost-effective development. In some cases, we do turnkey solutions, but in some cases, if our clients, if they have already software solutions, we use these components in the system for automation, in the system for testing. And of course, if they develop products, we try to adapt here as good as we can to provide effective services.
Okay, very good. Good. Thank you for the answers. So I think there is no more questions. So thank you again, Marcus, for presentation today and for being here. Thank you very much. And we can move now to our next speaker. It's a pleasure to introduce Dr. Ji Huang. She's the head of the fiber laser technologies at Cycle Lasers. Cycle Lasers is a manufacturer not only of fiber lasers, but also other solutions for high facilities or high advanced facilities, free electron lasers, synchrotron, low noise solutions. So, Dr. Huang, thank you for being here and ready to listen what you are going to present.
Okay, thank you for the very precise introduction. So I'm very glad to have this chance to introduce our 1 micron fiber ytterbium femtosecond fiber laser, which has a beautiful name, Sonata. So my first slide will be why we need Sonata. So Sonata is a 1 micron laser which has a relatively low power, but is very reliable and stable. So in principle, this laser can be a seed laser for a very high power ytterbium amplifier laser system, like the MOPA system, which laser can be the seeder for the huge amplifier chains afterwards. And what's more is like if you care about synchronization for the large laser facility, for example, like free electron laser facility and the extremely live infrastructure, you need to synchronize laser to laser together and to laser to the facility RF reference together. Then you need a no noise laser which has the function to be synchronized. So we provide a solution which has a very low noise laser and has a good performance for synchronization, and you can also use for any lab experiment, for example, pump pro experiment or other time critical experiment. So this laser has a simple structure, as you can see, it including a oscillator plus a preamplifier, and the laser have two output. The first output is the free space output. It has more than 100 milliwatt, and the output pulses is below 150 femtosecond transfer limit. And another output we call the fiber output, basic is from here, and the power is more than 10 milliwatt, and the pulse is chirp, is more than 3 picosecond. So this laser will be an ideal laser for amplifier from the fiber output, where you can use the free space output for synchronization to the facility or to other laser. And here I want to emphasize the advantage of this laser. So this is a single compact unit with electronics and optics all integrate into the same housing. So you just need to plug in the cable and turn it on, and the laser will be start in 30 seconds. And we don't need to do any alignment. It's hands-off operation. And meanwhile, it has very low timing jitter of pulses and very good intensity and performance. So we do here where you can see the output spectrum from the laser, which has a perfect Gaussian shape with more than 40 nanometer spectral bandwidth and center at 1030. And the output spectrum pulses has below 150 femtosecond and is a transfer limit shape. And the laser is centered at 40 megahertz. So if people want more repetition rate, we can customize for them. Here we do some measurement for the free running repetition rate drift. Use the frequency counter to see how good the repetition rate is, how stable the repetition rate it is. So we do a logging for 10 minutes. And it find out the standard deviation of the repetition rate only drift 0.3 hertz. So which means it's 0.03 ppm at the stable room temperature. So when I say stable room temperature, actually our lab is plus minus 1 degree. So within plus minus 1 degree, the repetition rate drift below 1 hertz in 10 minutes. But if we do longer logging for the repetition rate, it's drifting from 0 to 5 and drift back to 0. This is most likely due to the fluctuation of lab temperature, but it's within the range of 10 hertz, which is 0.25 ppm at the room temperature. And for this very small drifting, the laser actually is very easy to be synchronized and locked to any other lasers. And here we also measure the power log of the laser output, and we find out the power fluctuation is below 0.05% for logging of 150 hours. And for the short-term intensity noise, we are measuring the laser intensity noise with the signal source analyzer with the faster photo detector. And as you can see, the integrated intensity noise from 10 Hz to 20 megahertz is 0.025%. So this is a very low noise as far as I can understand. And with this performance, we try to do some measurement with the laser's timing jitter, because this is what we care about for a synchronizable laser. And when we want to measure the timing jitter, we have to use this setup from cycle. So we have to lock two lasers together with our BOC, which stands for Balanced Optical Cross Correlator, which is a very sensitive timing jitter error detector. And with this timing jitter error between the two lasers, we're sending the error to our electronics, feedback electronics, and the electronic feedback to one laser by locking them together to with a feedback bandwidth of 3 kilohertz, which means below 3 kilohertz, the two lasers are very synchronized. So we can calibrate the residual timing jitter between the two lasers from 3 kilohertz to 20 megahertz, and the measurement turned out to be 2.5 femtosecond between two lasers, the residual timing jitter between two lasers. If you consider the symmetric of two lasers is exactly the same, so the individual laser's timing jitter is half of this number, which is 1.3 femtosecond. But this number is still a little bit higher than the reality because the detected noise flow is also contribute to 0.7 femtosecond. So I will say each laser probably have 1 femtosecond jitter integrate from 3 kilohertz to 20 megahertz. To prove the ability of Zonato to lock to other wavelength lasers, we also test the locking between Zonata and Zupano. And Zupano is another laser in our company, which at 1.5 micron with 80 megahertz repetition rate. And we use this TC-BOC, which is a two-color BOC, to lock two different wavelength lasers together. The schematic is the same, and this is the sensitivity curve of the TC-BOC. By using 3 kHz locking bandwidth, we can lock these two lasers to below 6 femtosecond. And as you can see, this noise spectrum is a little bit different from before, because here we lock Zupano to Zonata instead of Zonata to Zupano. This is kind of this noise spec is coming from Zupano. And so in summary, we have a good 1 micron ytterbium fiber laser with very clean spectrum and pulses, and the free running drift of repetition rate is below 0.3 ppm. And the relative timing jitter is also below 0.03% with very low timing jitter. So far, the laser working at 40 megahertz repetition rate, but we are happy to tailor the laser output parameters to your need. And so this is the end for my presentation, and thank you for your attention. I'm ready for the questions.
Thank you very much, Jim. So again, we have time for questions, if any from the audience. I have one question regarding the use of the laser. If you go to this kind of facility with a free electron laser synchrotron, could your laser also be the substitute of one of the existing seed lasers, or should it be a new configuration where your laser is integrated from the beginning in the, let's say, structure of the whole laser?
No, so for large facility, usually we have a lot of laser which are commercials. So most likely we also do our own developing for like high power pump pro laser. But for the seed laser, usually is like commercialized. So they use the seed laser for seeding the high power pump pro laser. But the seed laser can be easily replaced because this is a low power. They only offer the power strength which for enable for to be amplified. So this is to switch the laser is not really a big problem because this is just a small part of the facility which they usually also just purchasing from other company. So this is what we're developing for because we have some problem beforehand for some laser systems which don't work so reliable, and we are developing timing systems for large facility, and we also want to have a reliable laser to work together with the timing systems. That's why we need to have a low noise synchronizable laser.
And any other application that you have in mind apart from laser labs or synchrotrons? Application, space, perhaps, communications?
Any application of this laser? Not yet, because this laser just newly released. But we have a lot of application regarding the synchronization of for large facility. So if you go to our website or you go to our publication list, you can see the synchronization of lasers for the auto-second timing jitter for kilometers link. So this is the in the past we'll have this publication. Yeah. For this laser, not yet. Yeah.
Yeah. Okay. I don't know if there is any other question from the audience.
I would be curious.
Thanks
for presentation.
Yes.
So just like for what does the application need? Like you showed these noise specs. Is it like, orders of magnitude too good or not good enough? Or so I'm just curious, like where are we standing this femtosecond? Is it high or low?
I would say it's already low enough, but I can't say this is a record low, but you have to consider noise is one perspective. So where our laser is low, I think this is similar to the record timing jitter, but also a lot of publication has auto second timing jitter measurements, which from my understanding is coming from the noise flow of the detector is kind of locking. So as you can see, there's a S curve of the balance cross correlator. Sometimes people lock to the flattened area of the S-curve, which is auto-second timing jitter, but I don't think this is a real timing jitter can be measured. So this is also the publication you have to be careful because some data is not really so trustful. But I will say this jitter already low enough for any application in a large facility.
Good. So thank you very much, Jim. Thank you again for being here this afternoon. Thank you for the presentation.
Thank you.
And we can move to our next speaker. So we have Diego Ormaechea. He's a technical sales engineer at Imagine Optic. Imagine Optic is a very well-known company. Adaptive optics is, I think, the key word for them, different metrology solutions. And he's going to present today the Mesosphere solution for planar parallel optic stenting. So Diego, the floor is yours.
Hi, everyone. Can you hear me?
We can hear you.
Okay,
Can you share your screen in your presentation?
I'm trying.
Good.
Okay, so hi, everyone. I'm Diego from Imagine Optic, and I will introduce our latest metrology system for optical components characterization. So, a brief introduction of Imagine Optic. We are a French company based at the south of Paris with between 60 and 70 people, and some offices in China, in United States, and in Bordeaux. We have also some distributors all around the world, and we are quite proud of two figures. So we have delivered now more than 2,500 wavefront sensors and more than 100 deformable mirrors for high-power lasers. So Imagine Optic is doing as two business units, sensing with the wavefront sensor from hard X-rays to short infrared, and some metrology system for optical characterization, live M² measurements. And once you measure the wavefront, the quality of the optical system, you can correct those optical aberrations thanks to adaptive optics. So that's the second business unit on the right of my slide, with different kind of deformable mirrors and adaptive optics solutions for telescope, for example. Today, I will talk about this metrology system, so MESO, which is designed for production environment and metrology labs. So with this system, you do not need to be optical engineer to measure the wavefront with a nanometer accuracy. And the idea of this system is to build an interferometer-like wavefront sensor, so close to the use of the very known ZIGO and FISO interferometers. And MESO can be complementary because it's keeping the advantage of the wavefront sensor, so it is insensitive to vibrations because we need one single frame to get the wavefront measurement. It can embed up to 4 sources, so different wavelengths. So in this new short infrared version, you can go from 1 micron to 1.7 micron with 4 different sources. For sure, there is an optical zoom in order to keep the high resolution regardless of the size of your sample. And we also integrate a new technology that we call POP for parallel optics procedure, where the idea is to measure parallel optics that are in general thin. And with an interferometer, you get a reflection from the back surface. So you can't measure really the surface flatness, the surface accuracy. And with this new procedure POP, you can measure both surfaces and the transmission of your optics without any preparation. So there is 3 types of procedure in the MESO system. The one I just mentioned for parallel optics, and then the 2 standard ones, transmission wavefront and surface flatness measurement, thanks to reflected wavefront measurement. You can measure different kinds of optical components. There is a list on the right of my slide. And now I will go on some example and some study cases to show some measurement. So first, an example about how you can measure parallel optics, mirrors, windows, substrate, or disk of any kind of materials by adapting the wavelength. So here it is an R&D team that was studying a new type of infrared material, and they were trying to get the refractive index inhomogeneity map. So to do so, we measured both surface flatness and the transmitted wavefront And by combining the three maps, we can get the refractive index inhomogeneity map. So on the top right, you can see the sample. And then bottom left, the setup. And in the middle, it's the wavefront measurement coming from the meso. We have an export feature in order to get a file compatible with MetroPro software, which is the most common wavefront analysis software. And that's it. Then meso can be interesting also for nonlinear crystals and laser crystals after coating. Sometimes you are not able to measure with standard wavelength of this kind of piezo interferometers. So here we measure the small cubic KTP crystals, 9 millimeter square cube, sorry. The wavelength is 1064 nanometer. We can control the polarization if needed, so linear vertical, circular, linear horizontal if needed. And for French laser crystal manufacturer, we developed an add-on on our software in order to measure in one single measurement a batch of different crystals. So you can see in the middle the raw camera signal of the measurement. You can see or guess 4 crystals, cubic crystals. And in one single procedure, then you can have access to 4 different wavefronts for the 4 different crystals. So you can measure a high number of crystals with just one measurement. Another example with some windows. In this case, it was for automotive. So you have a non-transparent windshield glazing that has been measured at 950 nanometer wavelength. And on the bottom left, you can see the raw measurement that require a high dynamic, more than 20 microns root mean square of aberration, deformation. So it's the wavefront distortion. And then you can use the mask editor of the software in order to have a measurement on an area of interest. Here it was a rectangle of 150 millimeter by 70 millimeter between the 2 electrodes that we can see on the right. Well, we can see that with the mask, the quality is better, less than 3 micron root mean square of wavefront error, but still some deformations that can be useful for simulations or to get some idea of the imaging performance of those kind of integrated optics in automotive. And finally, another example about optical system, beam expanders, and how to characterize external beams. So here we tested the meso in front, we put the meso in front of a wide LiDAR system that is supposed to have a very collimated beam. Currently, wavefront is not used to qualify these machines at the end of the production, but it is possible. The most common wavelength is 1550 nanometer. And we measured so this external beam, and at the end you get an independent measurement of the intensity on the right. But what is interesting is the wavefront on the left, the phase of the light wave. And we can then apply some model reconstruction, Zernike, and you can see some different coefficients that can be linked to real-world optical aberration. For example, comma is linked to decentering in the optical system, and spherical aberration, the 8th coefficient, is linked to the design of the lens, so you can do anything with the alignment. But for example, for comma, you can improve the quality of this external beam. It can be useful for guide star lasers or optical telecommunications terminals. That's the idea. Here's a reminder of the features of the meso and how it can be complementary to your current instrument in the metrology labs, insensitive to vibrations, for embedded wavelengths, and this procedure for parallel optics. Thank you very much. I hope it was not too restricted to the metrology and the wavefront people, but I'm aware to any question.
Thank you very much, Diego. Really interesting solution. Do we have any question on the room? You can raise your hand. I have one question because you mentioned different components, but what about coatings? You mentioned the crystals for the lasers after the coating, but can you somehow measure, or could be used for measuring the quality of the coatings, somehow the if the thickness is uniform through the surface. I don't know if you explore this kind of application.
That's exactly why we think that Shack-Hartmann wavefront sensor can be useful in this interferometry market and metrology. So there is more and more demand of metrology after coating. That is not the case currently and in the past because optics manufacturers are able to compensate for the deformation caused by the coating. But now we are able to measure at any wavelength, so adapt to the coating and not be in trouble if, for example, the component is not able to transmit or reflect with a red light or 815 nanometer. So that's typically why we develop meso, is to able to do some wavefront measurement after coating.
And also with multi-layer coatings?
Exactly. So multi-layer coatings, when there is a high number of layers, you can have some kind of interference pattern in the reflectance or transmittance curves of the material. And so on the operating band of the coating, in general, the surface accuracy is good, but in the edge of those specific coatings, you can have some strange phase distortion. For the moment, it's mainly problems for ESA and people who need very high accuracy phase behaviors, but it's gonna be more and more common in the industry in the future, I guess.
Okay, very good, very interesting. I don't know if there is any other question in the room. Well, if not, thank you very much.
Thank you very much.
I think the online meeting we will have in October about metrology could be interesting for you. So I will talk with you guys after this meeting as well.
You're welcome.
And we can move to our next speaker. So now we have Kimon Moratis. He's a photonics market analyst at the company TEMATYS. TEMATYS is a very well-known company because they prepare really nice market reports. They explore different applications. They also participate in European projects in the exploitation and dissemination activities. So we are going to listen about the global laser markets 2025. So Kimon, the floor is yours.
Okay, so thank you, Antonio, for the introduction and for the opportunity of participating in this product release event. I will share now my screen. Just give me a minute. I don't know if you can see my my screen.
Yeah, if you can put it in full screen mode,
Yes.
we can proceed.
Okay.
Everything good.
Okay, good. So today I will present you the report on the global market of lasers for the years 23 and 2024 that TEMATYS released in collaboration with Yole Group in January 2025. But before moving to the product presentation, let me tell you a few things about TEMATYS and its activities. So TEMATYS is a team of experts based in Paris, France, and we're committed to provide the most accurate and updated information on markets and applications of photonics technologies. The company has a versatile customer base, including large enterprises, SMEs and startups, research organizations, clusters, as well as investment firms. Now, alongside consulting and business intelligence services, the company publishes also regularly reports which analyze the markets of different photonic technologies. As a remark, our latest report is on the global market of ultra-fast lasers for 2025. Today, however, I will not talk to you about that. I will present you our main report on lasers that presents and analyzes all commercial laser technologies and their applications that, as I said before, we published in collaboration with Yole Group. So this is the first page of the report. On the left, you can see a small introduction. On the right is the list of authors who participated in each publication. And here is the table of contents. So The first chapter introduces the reader to the global market of laser sources for 2023 and 2024, as I said before. Now, here I need to precise that when the data were extracted and when we started drafting this report, we had access only to the market data up to the third quarter of 2024. So the market size of this year is estimated according to our internal knowledge and estimations for the fourth quarter of 2024. And of course, in a couple of months, we will release the update because our plan is to release yearly this report. So initially, the first slides are dedicated to the scope of this publication. So as I mentioned before, the purpose of this report is the study of the global market of laser sources, of the most common commercially available technologies and their applications. And then there are a couple of slides that are dedicated on the factors, both microeconomic and microeconomic, that influenced these markets for the 2 years. Then the reader is introduced in the perimeter of the laser sources, technologies and applications. And for those who are familiar with this study, the basic segmentation is based on the reports released in the past from Strategies Unlimited. Now, what it is different with this report, what is new, is that we introduce and we analyze extensively sub-segments which are more relevant to the markets of 2023, 2024, and 2025. As an example, under the segment of sensing and instrumentation, we introduce the sub-segments of semiconductor lasers for automotive and mobility, or for consumer electronics and wearables, and of course the analysis of their markets. Now, afterwards, we present like an overview of the market size of the different lasers technologies. Okay, so again, it's more like of a simple presentation in order to introduce the reader. Same with the applications, and the first chapter concludes with a general forecast up to 2030 for the technologies, the applications, both in terms of revenues and in number of units. And it also gives a list with the top 100 companies in terms of revenues out of the 400 in total that we analyzed for publishing these reports. So in the second chapter that is not going to be discussed in this presentation, we present in detail more technical aspects of the laser technologies that are analyzed in this report alongside their applications. And then in the third chapter, which is actually the most important part of this report, we start by analyzing the global market of each of the application segments and selected sub-segments that I presented you before in the introduction chapter. So here, as an example, I will present you the organization of a specific segment of lasers for industrial applications, and in particular for high power materials processing. So on the right, you can see a pie chart with the market size in terms of revenue of this specific application, and then the share in this market of the different laser technologies that are relevant, of course, such as CO2, fiber, disc lasers, and diode lasers. And on the left is a text, of course, which analyzes the industry needs and trends that drove actually this market during 2023 and 2024. In the next slide, this analysis continues. Inside the text, you can find more details about the market of specific subsegments, which are relevant always to kilowatt materials processing, such as high power cutting, welding, additive manufacturing, as well as a table that presents the market size in terms always of revenues and units sold of each one of these technologies, again, CO2, fiber, discs, and diode for high power materials processing. The fourth chapter presents a regional analysis of the market of lasers. So in the beginning, we present like the major laser sources manufacturers per geographical region, and then the global distribution of laser sales for the three main areas, EMEA, APAC, and the Americas, alongside, of course, an analysis that, of course, drove this market distribution. In the fifth chapter, we present a detailed forecast for the period of 2025 and for the period from 2025 until 2030. So in the beginning, the report presents visually these market evolutions by using bar graphs. Again, for the market size in revenues and in market of units. And of course, this is followed by a more detailed discussion showing an array with the exact values. Yeah, this brings me to the end of this report presentation. I would like to thank you all for your attention. If you want to learn more about TEMATYS and its business, feel free to visit our website or contact us directly. And yeah, I'm open to questions.
Thank you very much, Kimon. So we have time for questions. I have one first question regarding the analysis of the fiber lasers. I don't know if in this actual report, do you separate the figures depending on the wavelength, or for the moment is not needed? And if you see this possibility in the future, because we see that some 2 micron, 3 micron lasers trying to reach applications in certain materials, sometimes going also to the UV or the blue wavelengths. Do you think that is going to be in the future? And for the moment, you're stuck in the 1 micron area because it's the most common one?
So I actually right now, so we already did that, but again in an approximative way for the report we published on the ultra fast lasers market for ultra fast lasers for the industry. So we give a share for the ultra fast according to the 3 major wavelengths. So IR, green, doubled, and UV, blue UV, tripled. And now with TEMATYS, we are working actually on a report which will analyze the market of fiber lasers. Now, with fiber lasers is a bit more complicated to do this breakdown due to the fact that the range of applications is bigger. But of course, our idea is to try and do that and provide figures that are as accurate as possible. So we are on our way actually of constructing this database.
Yeah, I agree that it's difficult, and perhaps in the future we will see more clear applications related with certain wavelengths that will make the match easily. But yeah, I agree that for now it's like a little bit of 1 micron area, and then other wavelengths trying to find their position in the market as well.
especially for industrial applications, because for example, for medical applications, we know that
that's different.
It's mostly thulium-based lasers. So in that case, it is easier. But anyway, as I said, we are on our way of constructing this database.
Very good. Very interesting. Good. So there is no more question for Kimon, you have the contact details here in the screen. So please feel free to contact TEMATYS for any doubt or any comment about the report. And thank you for being this afternoon with us, Kimon.
Thank you.
And we can move to our last speaker today. So we have Chris Maloney, Director of Business Development at VPIphotonics. VPI offers different software solutions, simulation design, with a strong focus in the photonic integrated circuits, as far as I know. So yeah, he's going to present the new design suite version 11.6. So Chris, the floor is yours.
Yes, thank you, Antonio. Thanks for the introduction. Thanks for everybody for sticking around here today. I'm very excited to announce the release of VPIphotonics Design Suite version 11.6. This comes from a lot of market intelligence, but also conversations with our users to put new features, new application examples into the software. So for just a brief introduction about VPIphotonics, we're providing photonic design automation software, so simulation software, in the market for over 25 years. And we like to describe our software, and this is what we're always thinking when we're putting new developments in, is that it's integrated. So our photonic integrated circuit design solutions are integrated in the same design environment, user interface as our optical system solutions. So you can actually do simulations at different levels of abstractions very, very easily. It's also interoperable. So we support Python, MATLAB co-simulation so that you can put your custom models into the software. We also support communication with lab equipment. So we can communicate with AWGs and oscilloscopes as well. So bridging the gap between lab and software. And we claim to be industry leading. And so you'll see firsthand, I'll show some examples of us showing some of the industry leading simulation solutions for new technologies and new technologies that are being proposed. So you can explore those things and understand the trade-offs and the benefits. But we do have software tools that cover various levels of abstraction, from devices, simulating waveguides and fibers, to components, so photonic integrated circuits, also for fiber amplifiers and fiber lasers. And then transmission design, which is more system level simulation. So full optical communication systems, and then even network link engineering. So full fiber network design. But today we're focusing just on VPIphotonics Design Suite. So you can see the tools highlighted in blue there. So VPI transmission maker optical systems, LabX for interfacing with lab equipment. We support digital signal processing, QKD modeling as well, but also for the fiber optics, fiber amplifiers, photonic integrated circuits, and we even have a machine learning framework. So that's what I'm going to be focusing on today. I'm actually going to switch over to the software. You can see this is the design environment, and I'm not going to read through all of these, but later on, if you want to pause this, you can see a lot of the new features and application examples in the software. Everything from coherent free space optical laser satellite communications, supporting uplink, downlink, ultra wideband transmission for coherent WDM systems, PAM6 modulation, optical DACs, digital analog converters. We even are supporting more electrical modeling. So we are now supporting Verilog A models in the software. So for those who are doing electrical optical co-simulation, new capability. And we have a number of new mode lock laser demos as well. And even some new setups with lab equipment from Keysight's AWGs and oscilloscopes. So I'll just show a couple of examples. The first is enabling coherent FSO communication systems. So we have a new coherent FSO channel model. And what's new about this is that it's modeling signal propagation through turbulent atmospheric channels, but it's also now supporting adaptive optics compensation. So we can see how different Zernike polynomials can correct the wavefront aberrations through simulation, and coupling into single mode fibers. So what I think is really neat about this is you can really explore, oh, how much compensation do I need from adaptive optics? But then also compare it to, digital signal processing. How much of a correction can I get from the DSP chain as well? And so you can compare and contrast and explore those trade-offs. If you just want to see an example of the simulation results, you can see like your constellation before and after DSP for a number of different simulations. So you can see how turbulence through atmosphere changes your constellation diagram. Another quick example, new to the software, is this 800G DWDM system. This is really focused on, it's a representative architecture of NVIDIA's new optical circuit switch that is based on silicon photonic microring modulators. So if you just take a quick walk through the schematic, you can see there's multiple laser channels, so different wavelengths, so 8 different wavelengths in this case. We use this red GUI interface to represent an array of lasers. There's an array of silicon photonic microring modulators as well. Those are connected in series. You have your fiber. You have a demultiplexer over here based on three-ring filters, so photonic integrated circuit components, and then an array of receivers as well. So you can do different things like tune your microring modulators to optimize your performance. You can get an idea of some of the results seen here. So we can look at the optical spectrum before and after the transmitter, the eye diagram, and symbol error rate or bit error rate at different channel positions. So I'm going through these quickly. We do have more information on our YouTube channel about these. If you want a more in-depth peek at some of these simulation examples. Another exciting one, this actually comes from some work from the European project, the ELENA project, where we helped model thin-film lithium niobate modulators and supporting some of the PDK elements that came out of that. This is a coherent system based on optical frequency comb and a thin-film lithium niobate IQ modulator. And so this is really where the excitement is, and is in this IQ modulator. If we look inside of that, you can see it's made up of these photonic integrated circuit components, so MMIs being used as couplers, but these electro-optical phase shifters, which if we take a look at this, you can see this is a new element in the software. So the electrode length is actually made up of multiple segments based on measured S parameters. We can bring in those measured S parameter electrical measurements. We can specify load and source impedance and others. So that's a new component in the software that supports the full system level simulation of an optical transceiver. And then one more example before I wrap up here is, in addition to all the new capabilities for different technologies, we have basic user interface improvements as well. So one of our active models on the photonic integrated circuit side is the Photonics TLM model. So you can model lasers with these. It's a very powerful model. It includes Kerr nonlinearities. You can investigate carrier dynamics, spatial hole burning, 2-photon absorption. It's a very sophisticated model. One of the challenges with that is that it can also be difficult to use. So we add some ease of use capabilities. This is a multi-section device model. And so in this case, we have an active section. If we want to quickly add an EAM section, we can do that. We can actually visualize the device length as well, upload that, and you can see visually what's going on and how you can make those changes to the device themselves. And then when you click finish, all of those changes graphically get implemented within the model itself. So if you actually look at the parameters, You can see if I look at the device section, there's your active section, your EAM. So it just makes this a little bit easier for those who maybe don't have as much experience with it. But with that, I'm going to wrap things up. And if you're interested, feel free to reach out. There's the sales email. You can email me directly as well. We offer demos. We offer software evaluations of Design Suite 11.6. And coming up at ECOC, we will be running a workshop on simulating data center interconnect systems based on thin film lithium niobate modulators as well. So follow us on LinkedIn, subscribe to our newsletter. More information is going to be coming up about that, and that will be supported by Epic as well. So yeah, thanks for your attention.
Thank you very much, Chris. Really, really interesting. Is there any question for Chris? I could have one regarding the thinking in a user of this kind of software. How often that they need to adapt the solution, let's say, to their application, and in this case, if it's often that happens, how is the support that you can provide them? If they need to be really experienced on that to work with it, if they can, you mentioned already that for some unexperienced people, you have also solutions. How is normally the process for somebody that is developing?
That's a great question, and there's a lot of different answers here. So first, the one thing we're keeping in mind is that some of the startups, they have a single team working all the way through that workflow that you've seen. Some of the larger companies, they have teams dedicated for designing the PIC, and then another team for designing the full optical system. And those two teams have to work together. So that's why we're providing the solution in a single user interface. So if you are on a small startup and you're working all the way up through this, it's very easy to stay in the same software, the same interface. You're not jumping between different softwares, importing and exporting files. It's all in one seamless workflow. It also makes it easy for different teams to work together because they can just share a single schematic that includes both the PIC and the system. This is something that is becoming more and more important because one of the trends of the industry is that we need to take more of a systems approach to photonic integrated circuits. They've reached some level of maturity where now, they need to be designed taking into account the full system.
Very good.
It looks like there's a question from Kimon as well.
Yeah, please, Kimon.
Yeah, I have a question. So you mentioned in your presentation that your software can also simulate nonlinear processes. Okay, such as, can you give some examples?
Yeah, so actually, maybe relating back to your presentation, we do have tools. I didn't really cover it here, but for simulating fiber lasers and fiber amplifiers. So we do have some doped fiber modeling, some physical modeling capabilities in the software. So this can include, doping concentrations, the doping profile, co-doped erbium ytterbium co-doped fiber lasers, and what we can model are the energy transitions. Okay. And so then in our fiber model, all the Kerr nonlinearities, four-wave mixing, Raman scattering, Beryllian scattering as well can all be modeled and taken into account in the software as well. Okay. So you could do the physical modeling, and then you can take that, turn it into a black box model, and use it in a full system simulation as well.
Have you considered it's a question for the future to implement also a simulation toolbox mostly related to simulations for companies which are developing hardware for quantum photonic computing, or you think that?
Yeah, so we were partners in one of the European quantum flagship projects, Unicorn. And so we do have capabilities and examples in the software for designing, for example, like a QKD transmitter. And what's interesting about that is that's a PIC being used for quantum applications. It's not necessarily a quantum PIC, right? It's a low light level transmitter. So depending on what you need, yes, we can support that. And I guess what's interesting about that is we do have a QKD toolkit in the software. So if you want to see how the performance of that, QKD transmitter impacts the quantum bit error rate in the end, those are types of things that can already be explored in the software.
And how about spontaneous four-wave mixing? Have you considered also developing a toolbox regarding this technique, or?
So we do our fiber model and our Photonics TLM model. It does include four-wave mixing in the capabilities already.
Okay. Okay, thank you.
Yeah, thanks.
Thank you, Kimon. Any final question for Chris or any other question? If not, well, thank you again. Thank you for sharing your contact details. So anybody interested in simulation design, please contact them to discuss your needs and your ideas. So you could probably find a product from VPI that will help you in your process. And well, it's time to finish because yeah, it's already 5:10 p.m. So again, thank you to all the speakers we have today. Thank you, Marcus, G, Diego, Kimon, and Chris again for the presentations. We will upload the videos to YouTube so you can share again and then check what they discuss, and we will upload also the presentations. And again, I mentioned that it was planned to have a presentation by Max Körner from Häcker Automation in their new OurPlant Smart Tools. But unfortunately, he cannot join today, but we will upload the slides to our website. So I encourage you to go there and see what his idea for presentation today. I see that Chris also put his email in the chat. So please contact all the people if you are interested, and nothing else from my side. Only wishing you a good afternoon, good summer holidays for those of you who are still waiting for them, and see you in the next EPIC meeting. Good afternoon, everybody.